So welcome back to Computer Vision. We're talking about doing tracking. Now, last time we introduced this idea of tracking as induction. That is, if I know what's going on at time t, or I have some belief about the state of the universe at time t, I make a prediction for time t plus 1. Then based upon that prediction, that might affect how I go get my measurement. I get my measurement, it's noisy, and I correct for t plus 1. And that continual loop, that's what we mean by tracking. And we did a little bit of sort of onerous mathematics where we talked about that the prediction part leveraged two things. It leveraged our belief of where we were the last time. That makes sense in, right, in terms of we might believe the position, we might believe the velocity or something. And we had to have a dynamics model. That is something that tells us about how things will change. All right? So given some belief about how things were and how things might change, that gives me a new belief about where things might be. And then the correction, the update after we took a measurement, remember we made use of Bayes' rule. And the idea is we take the prediction, we multiply that by a likelihood, and we'll talk more about that not so much today, but next time. And combining those and then normalizing allows us to know the prediction, our best guess now, of the state at time t after the measurement at time t. And that was referred to as the posterior distribution. So today we're going to do a specific case of what's called linear dynamics, all right, where the predictions are based upon a linear function of our current belief. And we're going to assume that we've got Gaussian noise both in terms of how things might change. So we have a distribution, we believe how things might change, plus there's some noise added, Gaussian noise. And furthermore, we're taking measurements, and our measurements are a function of the state plus noise. What kind of noise?
Gaussian noise.
Very good. And we'll show a simple linear recursive filter called the Kalman filter that's designed to handle this nice clean case.